Hello everyone, Missy here today, and we will be writing and expanding multiplication expressions. So on our agenda today, we have materials. So a paper and pencil are always best, but if you have anything to write with and write on, that works as well. If you have an electronic device you want to follow along with, that'd be great. And if you didn't have anything, just going along with what we're doing today is going to be great too. So I have the joke here, why should you never talk to pi? And then make sure you remember that pi is in that PI. So after we go over the objectives, I'll give you about 2 minutes to go and get those materials, and then we'll come back for the joke. So our objectives for today is I can identify parts of an expression using mathematical terms for multiplication. So if you want to pause here for about 2 minutes, we'll go over that joke after for you to get those materials. If you already have that, then you can just think about the answer. So coming back for the joke of the day, why should you never talk to pi? It's because he or she or it will go on and on and on and on forever. So if we know what pi is, that's like the 3.14 that we know, but it's actually a number that is infinite and it goes forever and it's never ending. So moving on to our review for today, we have the commutative property of multiplication. So when two numbers are multiplied together, the product is the same regardless of the order in which the numbers are multiplied. So in the example I have on the screen, I have A times B equals B times A. So basically 5 times 1 equals 1 times 5. So if you do it either way, you'll get the same answer. So what does it mean to evaluate an expression? It means to solve the expression, so finding the answer. And then for vocabulary, we have variables. So it's a symbol that stands for a number, A, B, C. Commonly, you'll see in math, you'll see X and Y. Those ones are the most popular, but you can use any letter you'd like. And then expression, a math phrase that is made up of numbers and operational signs. So we have plus, minus, multiplication, and dividing. So those are vocabulary words we'll be saying a lot throughout the lesson. So let's start thinking. When we want to show multiplication of two numbers like 5 and 7, we typically write 5 times 7 using the X to show the operation. And then when we start to use variables with multiplication, we can use other forms. And those forms are A times B using like the little X. We can use the dot, so that also means multiplication as well, but then you won't get confused with the variable that could be possibly an X or multiplication symbol. And then you can put them next to each other. We have on the screen just A, B, but that could get confusing later on because you can mess up the numbers, but that's also another way. And then my personal favorite way is doing the parentheses. So then I have parentheses A, and then close parentheses, parentheses B, close parentheses. That also means multiplying A and B as well. So let's start thinking. Why might we want to use a form other than the multiplication symbol, that's the X, when variables are involved? And then which of the three models can be used to show multiplication where there are no variables involved? So I'll have you guys stop here for about 2 minutes to go over those start thinking questions. All right, I hope that was enough time for you to go over those answers. So we will do them together. So if you didn't get to it, no problem. So the X can be confusing for a variable instead of a symbol for an operation. So like I said earlier, if you had like A times B X, So if you want to do A times BX, you could get confused on what one it would be. You could think it's AX, BX. So that could get confusing later on when you're using variables. And then which of the three models can be used to show multiplication where there are no variables involved? So we have on here 5 times 7 using the time symbol, and then 5.7, which also means multiplication, and then parentheses 5, parentheses 7. But not the one that's next to each other, that was 5 times 7, because it looks like the number 57 and not 5 times 7. So before we begin, when writing expressions using the fewest number of symbols, we have to refrain from using the symbols times, multiply, or the parentheses. We will also be using math terms to describe expressions, and the parts of an expression, we will be using words like factor, product, quotient, coefficient, and term. So those are the terms we'll be using. So a term is a part of an expression that can be added to or subtracted from the rest of the expression. In the expression 7 times G and plus 8 times H plus 3, what are examples of terms? So G7, 8H, and 3 are all the terms. And then the coefficient is the constant factor in a variable term. For example, in the term 4m, the 4 is the coefficient. So the number is the coefficient, and it's being multiplied by the letter or the variable. So let's do our first example. Write each expression using the fewest number of symbols and characters. Use math terms to describe the expression and parts of an expression. So we'll do these together, and then I have some for you guys to do on your own. So A, here we have 6 times B. So this could look a little bit confusing because it could be 6xb. So we are going to find another way to write it that's less confusing. So we can write it as 6b, and since it's a letter, it's a number and a letter, we know that those are going to be multiplying because it's not the same, like two numbers together or two letters together. So in A, the 6 is the coefficient and the factor, and the B is the variable and the factor. We can call 6b the product, and we can also call it the term. So the product is the answer of 6 times b, and then we put 6b next to each other. So for example 1b, we're doing 4 times 3 times h. So if you want to do that just on your own for a second, and then I'll go over how I did that. So for this one, I multiplied the two coefficients together, the 4 and the 3, which got me 12h. Because you can multiply the numbers together, but you can't multiply the variable just yet. So I got 12h, like it is on the screen, and then the 12 is the coefficient and the factor, and the h is the variable and the factor, and then we can call 12h the product, and we can also call it the term. And then for example C, here, we have 2 times 2 times 2 times A times B. So that's a lot of time symbols there. It could get confusing. I would be extremely confused if I saw that. So take a moment again, try to figure that out on your own first, and then I'll go over the answer. So for example, 1C, like I did in B, I multiplied the 4 and the 3 together. That got me 12 because they're both whole numbers. So I can do the same here with all the 2's. So when I multiplied 2 times 2, that gives me 4, and then 4 times 2 gives me 8. And then I have my A and B. So then I have 8AB. So 8 is the coefficient and the factor, and then A and B are both the variables and the factor. So we can't combine like A and B into one because they're two different variables, two different letters. So if it was A times A, it'd be like 2A. And then 8AB is the product and also the term. Moving forward, we have another example. So one important rule when rewriting multiplication expression is that variables always follow the numbers and should be written in alphabetical order. So on our example here, we have 5 times m times 3 times p. So we can combine, again, the numbers. So 5 and 3, we can multiply them together, and then M and P, we write them in alphabetical order. So you could have like A at the end, and you want to make sure you put A first, just so that you look at it and it could be a little bit more clear. So when I combine 5 times 3, that gives me 15, and then MP. 15 MP. So 15 is the coefficient and the factor, and then again M and P are variables and the factor. So 15 MP is the product and also the term. Again, we couldn't combine M and P together as one like we did with 5 and 3 because they aren't the same. So you can gather the number together and the variables together. You can do this because of commutative property of multiplication. So like we were talking about earlier, you can combine them all together because of the commutative property. So what happens when you multiply by 1? So I'll give you about a minute or two here to think about that answer and see what you may get. So just pause for about a minute. All right, so when you multiply by 1, multiplying by 1 is an example of the identity property. Any number times 1 is equal to that number. Therefore, we don't always need to write 1 because 1 GW is also equal to just GW. So like we know that 5 times 1 is always going to be 5. 5 times or 1 times 100 will always be 100. So since we know that 1 times any number will always be that number, we don't really necessarily have to put it in front of the variable unless you really, really, really want to, but you don't have to. And we encourage you not to just because we already know. So looking at the answer, I know it's going to be 1 GW. All right, so for example 2, we're going to expand multiplication expressions. We will rewrite the expression by including the dot multiplication symbol back into the expression. So what we did earlier was we took all of these and then put them in this form where we had them next to each other. So now they gave it to us next to each other, and then now we're going to expand it out into the first way. So for A, I have 5G, so 5G, so then I know that is 5 times G. And then for B, I have 7ABC. So then I do know when I expand it out that it's going to be 7 times A times B times C. And then C is 12G. So then you could write it as 12 times G, or you can expand out even further and multiply it as 2 times 2 times 3G, times G. So what you want to do when you expand it, you want to write it in the smallest number possible. So you could have wrote it as 4 times 3 times g, but 4 can be even further. You can go even further with 2 times 2. So you guys can pause here for about 3 minutes and try those two on your own. D and E. All right, so the answers for D and E is 3 times H times 8. And then for the answer for E, it was 7 times G times 9 times H. Or you can expand it further with the 9 and do 7 times G times 3 times 3 times H. So that's what you do when you would expand that out with those answers. And again, I said with those numbers that can be multiplied, you can expand that even further. So we have these here for you guys to try on your own. So I will give you about 8 minutes to do these on your own, and then I'll go over the answer with you. So pause here for about 8 minutes, and then we'll go over the answer. All right, I hope that was enough time for you guys. So now that you've known how to expand it and then turn it back into multiplication form, we had both here and I have the answers. So 10 times m, you could do expand it out to 10 and then times with the dot sign m like this. But again, I said you have to expand it even further if it can be multiplied. So here we have 2 times 5 times m. And then for number 2, I have 8 times 3 times m. So then we turn that one into 24m together. And then when we multiplied for number 3, we had those parentheses. So when we multiplied 3m and 9p, we can multiply the two coefficient numbers together, and that gave us 27, and then combined the m and p. So 27mp. And then we have 1 mpt. So then, like we said earlier, if it was multiplied by 1, you don't have to put that 1 in front of it. So we have the answer of mpt. And then number 5 has a coefficient of 5. So 2 times 5 times m. And then number 6, 10mp times 4t. So then I combine the two coefficients together, and then I get 40, and then I get mpt when I combine the variables together. And then for number 7, I have 2 times 7 times m times p. So then again, I can multiply the two coefficients together. That gave me 14, and then m times p. And then 8 has a coefficient of 3, so then you can use any numbers you want for this. And number 5, forgot to mention that, you could put anything you wanted into those, but you have to have the 5 in it for number 5, and then for number 8, you had to have the 3. So for 3, we used 3 times m times p, and then for 5, we expanded it out and did 2 times 5 times m. So those are your try-own answers. So let's finish up. So what is the difference between standard form and expanded form? So I'll give you guys about a minute to think about that on your own, and then we can go over that. All right, so when we write an expression in standard form, we get rid of the operation symbol or the symbols for multiplication, and we write the factors next to each other. So that's what we did when we had like 3mp, 5 ABC. So that's what we did when we expanded it out. I mean, when we got rid of the multiplication symbols and wrote the factors next to each other. So again, our objective for today was I can identify parts of an expression using mathematical terms for multiplication. So we learned like product, coefficient, variable, term. We learned all those and used those while we were talking. And then we also learned to expand expressions using multiplication and those mathematical terms together. So you expanded the coefficient and then you had the variable as well and then multiplied them all together. So that was just a little example of what we covered today that went with our objectives. So if you want a little bit more of an extra practice, you can go to Algebraic Expression Basketball. So on my link, you can click it, but let's see if we can get to that. Perfect. So it's algebraforchildren.com. So then this one is a basketball game that helps you with algebraic expression. And then you can play along and it gives you like the expressions in math. And then let me go back to the slides. And then we have write variable expressions. So we can click that one as well. And that's mathgames.com. So then you can write the expression, write the following. I got it wrong, but it's something like that. So that is what we have for today. And I hope that those games are super fun for you guys to review those answers. So thank you.